All right, welcome everyone to Flyte School. This is episode, I believe it's number 6, and a special one because we have a fantastic guest today, no other than Mr. Kevin Su, a core maintainer for Flyte. And Kevin will be leading a deep dive session on all things Flyte plugins. As usual, please drop your questions in the chat. We'll try to answer them as we go. And yeah, let's start with just share with us in the chat where are you tuning in from? Where are you based right now? Where are you joining us from?
Yeah.
Right. Cool. Cool. So I think we can get started for now. Can just share the screen, Kevin.
Okay, sure. Thank you, Debbie. Let me share my screen. All right. Hello, everyone. Welcome to Flyte School. And then today we're going to deep dive into the Flyte plugin, and then we're going to explore what existing Flyte plugin, what kind of Flyte plugin we have, and then we're going to teach you how to implement, and then when to why do we need to use plugins. First, I'm Kevin. I'm software engineer at Union AI, and we are based in Seattle. And then I'm an open source team, and my daily job is to maintain and develop our open source project, Fly. And then I love to contribute. I contribute to open source. I have contributed many other open source like Hadoop and Summary. And then in my spare time, I like to play basketball, go hiking. So if you're in Seattle as well, let me know. We can play some plugin. Yeah. So today's agenda, we're going to talk about the backend plugin. In Flytekit, we have two kind of plugin. One is backend plugin, one is Flytekit plugin. And then we're going to deep dive into these two kind of plugin. And then I will go through the code and tell you how to implement this kind of plugin. And then I will give you a demo, and then in the next session we'll give you some time to ask some question. Okay. Before we go into talk about the plugin, let me talk about the Union Claw. So Union Claw is a managed version of Flyte that offers advanced observability and then robust RBAC support. So, which means if you want to use Flyte and then you don't want to worry about the deployment, you can use Union Cloud. So you just register your workflow to Union Cloud, and then everything is run on Union Cloud. You don't need to worry about the deployment, and then you don't worry about the maintain your own Kubernetes cluster. So if you are interested in the Union Cloud, you can scan the QR code, and then this QR code, we have a hosted Flyte sandbox, and then this sandbox will be running on our our cloud. So you can register any workflow to this sandbox and try to run anything on the sandbox and try any feature in Flyte. And then if you want to see some demo, you can scan the right QR code, and then we will schedule some time and then give you a demo. Yeah. So let's talk about the simple workflow and why is the workflow orchestrator. So first of all, there are lots of workflow orchestrator in the world, and then what people usually do on workflow orchestrator is that they define your data pipeline, ML pipeline, and then they use workflow orchestrator to workflow orchestrator will help you allocate the resource some distributed system like Kubernetes or like AWS ECS or something else, and then you will traverse your DAG in the workflow, traverse your DAG, and then find specific node to run, and then Each node will be run on a separate container or separate process or separate pod, and then the workflow scheduler will help you save the output to the block store. This is a very simple workflow, and many workflow orchestrator can do it. But the problem is that when you have more and more data, and then you will run into many problems, and you'll see a lot of challenge in the data pipeline. Is that how do you move data faster? Sometimes your data will in the different will store in different region, and sometimes maybe you store in different cloud provider, and then you will run into any issue like how do we move data from like in the East Coast to West Coast? How to move it faster? And then this is the main problem in the data pipeline. And then another problem is that when in your data pipeline, you not only want to run the Python code, sometimes you want to run a SQL query in your pod, or like you want to run a BigQuery or Snowflake in your data pipeline. And then when you have and then another problem is that you want to save the money, so you want to run some text on the Spark machine, or you want to run some text on some cloud service like Lambda or AWS Batch. And then if you have more data, you must use Spark cluster before. And then the problem is that many of our users, some of our users we hear some feedback from our user, and then not many company have internal Spark cluster, and then they don't have capability to maintain this Spark cluster. They want to run a data pipeline, and then they want to run the Spark job, and then they want to use it only when get off this text. So which means like they want to delete this cluster after the text is complete, and then they don't want to maintain it. And then after data processing, you will run into another problem in machine learning pipeline, and then others challenge. So first is that how to monitor the model metric and then parameter on your workflow shader UI. Yeah. And then how to do distributed chaining. A lot of workflow shader can run the Python code, but they cannot run the distributed chaining. And then how to manage the Python dependency. Yeah. So if you want to run the task on Kubernetes, the first problem is that you need to build the Docker file, and then if you want to run your task, your workflow on a distributed system, you don't figure out how to install this Python dependency on this distributed system. And then for now, Ray has become very popular. Like a lot of people want to use Ray, but the same problem. Like a lot of people don't want to maintain a Ray cluster internally. Yeah. So these are the problem in the machine learning and the data pipeline. So that's why we built Flyte. So Flyte, let's take a look at Flyte first, and then let's give you an overview. So Flyte is built on top of Kubernetes. So everything is built on top of Kubernetes. So first, the first problem when you run task on Kubernetes, you need to write a Docker file. So that's why we built a plugin called ImageSpec. Here it's a plugin. It's a image definition you can write in your Python workflow. You tell us what's the Python dependency you need, what kind of environment variable you want to add, and then we will help you build the image for you when you register the workflow. So you don't need to write any Docker file, and then we will automatically push your image to the container registry. And then after you deploy the workflow, you want to run your workflow on Kubernetes. We have a component called Flyte Propeller. It's a Kubernetes operator, and then it will help you manage your workflow lifecycle. What this propeller can do is that the first thing it can do is that it help you schedule and monitor your workflow. It can like launch a pod on the Kubernetes, and then second is that if you want to run the distributing or distribute data processing, it can help you create a cluster here on the Kubernetes. Or if you don't want to run any tasks in the Kubernetes, we can the propeller can talk to the other system, like submit a job to the AWS batch, or like send a request to the external plugin systems. And then another yeah. Let me talk about the first plugin. It's called ImageSpec, and then it allows you to build the image without Docker file, and then you can help you build multi-arc image. And then here we use the open source project called Empty. It helps you to build a smaller image, and then it can build the image much faster than using Docker. And then one of the cool things in the image spec is that when you try to build an image and then try to push the image, we will hash your image spec, and then your image name or your image URL will become like flytearc/flytekit/hash. We push it to the container registry. So every image in your container registry has this hash. So Flytekit will know what's this image, what kind of dependency have in this image. So first, for example, like if data team use image spec, and then they push the image to they register workflow, and then Flytekit will help you push the image to container registry. And then the ML team, if they use the same image spec, Flytekit will go to the container registry to search this image and then pull it. So you will not rebuild it again. So the problem when you use Docker file is that people keep building the same image again because they forgot which image they push before. So that's why we build the image spec. And then in the Flytekit, we have a plugin called image spec plugin, and then it contains a builder. It have a image builder engine, so which allow you to create another image spec builder. We use by default we use OpenSMD to build the image, but you can also use any other tool you want to build an image spec. Image spec is high level, just a high level image definition in Flytekit. Yeah. So another feature, another plugin is called Flytek. In our Flyte console, in our UI, we have a feature. We have a pop-up window, and then you can see. You can explore your data or see the model metric on the UI. And then in the plugin, in the Flytek plugin, we have bunch of the render you can use in your text. For example, if you want to want to explore and want to see the Panda data frame on this UI, you can use the table render, or we have another render like table profile render, which allow you to profile your Panda data frame. It will show you the distribution of your data frame. Yeah, and then we have a decorator. You can we integrate the MLFlow. We have a MLFlow auto log decorator you can use, and then it will automatically log your model metric and then show this metric on the Flyte console. Yeah, when you run the tags, and then another plugin is data persistent plugin. So when you run the tags in the pod, or you want to run the tags in the cloud, by default we use the another open source project called FSspec to download, upload the data. When you try to when the task is complete, it will push the data to S3 bucket or GCS bucket, and then when the task start, before we run the task function, we will help you download the data to the pod. Yeah, but we use FSspec, but the implementation of the FSspec is very slow. So one of the contributor in Flytekit, they add a ROS data persistent plugin. You can see this chart. It's much more faster than FSspec. So if you want to like have much better performance, you can re-implement your own plugin in C++ or ROS. Yeah, and then sometimes like people want to save their they don't use cloud. They want to save the data to their on-prem storage like Hadoop or any other storage in their own protocol. They can implement the data persistent plugin internally, so they can register this plugin in Flytekit, so Fly will know how to write this data to your own storage. And then another cross project is Skyplane. So if you have a data across different region or different cloud provider, you can use Skyplane. You can move the data, and then you much faster and then much cheaper. So let's talk about another backend plugin. So when you have more and more data, you may want to use BigQuery. So but the problem is that you don't want to run a BigQuery tag. You can BigQuery is running on GCP, and then you don't want to run a pod to submit this request to the GCP. So what we does is that in the propeller, we instead of creating the pod, propeller can send a request. It will create a Go routine and then send a request to the BigQuery without launching the pod. And then when you after your job's complete, BigQuery will save a resource table. Save a resource in the resource table, and then you can create a structured data set. Structured data set is a virtual data set, a virtual data frame built on top of BigQuery, Snowflake, and then Pocket, Arrow, and then many other data frame built on top of it. So structured data set is, you can imagine, is a reference of the data frame, and then it contains in this shared asset will contain some information like format, the URI, and then the schema. And then after you run your BigQuery, Fly will create a shared asset for you. And then when you pass this shared asset to the next tags, for example, you pass a shared asset to your chaining tags, you can use the built-in data transformer. We call the encoder and decoder. You can decode your shared asset to the Panda data frame or Arrow data frame or Spark data frame. We help you to do that. You don't need to figure out how to download the BigQuery data, how to transform this table to the data frame. You can decode it in the one line, and then after you do the data processing by using Spark or like any other tool, you can use encoder to encode this data back to the BigQuery, or you want to save this to Snowflake. I will show more detail in the demo later. Yeah. Another plugin is called Spark plugin. So people don't want to maintain the Spark cluster, so we leverage the Spark operator in the Kubernetes, so which can help you dynamically create a Spark cluster, and then you can run the data processing on multi-node. And then the only thing you need to do is that you create a Python tags, Flyte tags, and then you write your PySpark code in your function. And then one thing you need to add is the Spark config here. The Spark config define like how many driver node and then how many executor you want to deploy on the Kubernetes. Once you define your Spark config, once you register your workflow, we will send this information to Propeller, and Propeller will know how many driver and worker you will create it for you, and then run this Spark job on this driver and then worker node. So so it's very simple to start it. You don't need to maintain, or you don't need to create a Spark job on your own. You just define your cluster like infrastructure as code, and then in your workflow file. So why do we implement the backend plugin? Because when you get more and more data, your use case get more and more complex. You want to run many. You not only want the tags in the pod. You want to run many serve. You want to run many service, external service, AWS service, GCP service like AWS SageMaker or Snowflake in your workflow. So you may need to implement a backend plugin to give Propeller ability to talk to other service. And then another use case is that if you want to run like distribute chaining and then like streaming processing, you need to implement another backend plugin to create a Spark cluster, or like create a multiple pod to run the distribute chaining. And then sometimes another interesting use case is that some of our user they deploy Fly on their own, but they have a very small Kubernetes cluster, but they don't run any pod any tags in Kinetics, they use our current AWS batch plugin. They run everything like AWS batch. So they just need to have a very small Kubernetes cluster, and then the benefit of running on AWS batch is that you because they don't run they don't have too many workflow they need to run every single hour. Yeah, so they can submit a job to the AWS batch like Spa, and then use the Spa instance to save their money. And then another use case is that you can implement another backend plugin to run your tags on the AWS Lambda. Okay, let's jump into demo. One second. Okay, so the first example is that this is a very simple workflow. You can use Python run this example. This very simple hello world example. You can run this locally, and then if you want to register this workflow to our cluster, you can use another demo, and then you will register the workflow to the cluster.
Kevin, can you zoom a little bit?
Oh, sorry. Yes. Maybe let me use. Okay. How about now, David? It's better?
Yeah.
Okay.
Thank you.
Okay. So you can register your workflow to the remote cluster. Oh, by the way, I upload all the example to this GitHub repo, ping/tw/flyhop, and then Flyte School directory. This directory contains all the example we're going to demo today. Okay.
Cool. I will add it to the comments for sure. Thank you.
Okay, thank you. All right. So here you can see the workflow statistics. In this example, we use the default flytekit image, which is flyout/flytekit 3.10 lattice. Yeah, it's good. But the problem is that if you want to use TensorFlow in your tags, and then if you register this workflow again, oh, sorry. Oh. Register. Okay. Let's see. Oh, sorry. Yes. I researched around cluster. Yeah. Okay. If we go to the Flyte console, and then it's the text file. The reason is that in the default Flyte image, the only dependency is Flyte. So if we try to use any other package, it will show the error, no module. So what can we do? Like, we can use the image stack, and then we can create the image. And then the first thing you need to specify is the registry. It's a your container registry. Like for example, I use Docker Hub, so I use the my Docker account here, and then you can specify. Okay, thanks to the compiler. You can specify what kind of dependency you need for these tags. That's it. In this demo, we only install TensorFlow, so you can specify your container image and use image spec here. So for now, let's register the workflow again. You will start building your image, and then in this case, you find that we already built this image before. So you find the image on my Docker Hub, and then use this image name and replace this with this image name. And then we go to the Flyte console, start initialize, and then start running. Good. And then you can see yeah, succeed. Yeah, because for now we are using the container which has TensorFlow dependency. Yeah. So this is the image spec. So if you add another dependency, a random dependency here, and then you register this again. Oh, let me use not. Yeah, so this time it's an image not found. So we use empty to build the image. You can see here, start building the image. Yeah. So this is why we use image spec. You don't need to use any Docker file to define your image in your workflow code, and then Flyte help you build and deploy the image for you. Okay. Another example is like that. So let's say you have a panda data frame, and then here we import a 2D render in the Flyte plugin called frame profiling render and table render. So let's say you have a panda data frame, you want to profile it, you can use this render and then use this render to generate a HTML string, and then you can add it to the flight deck, and then this flight deck. And then if you want to use you want to use your own render, you can create a class called image render, and then the only function you need to implement is to HTML, and then you in this case the input is the pillow image, and then you tell Flyte what you need to do is that you need to override this function and then convert this image to a HTML string, and then if you register this render, then Flyte will know how to render this image on Flyte deck. And then, for example, like I create another text. This text will download this image, and then we use our custom image render to render this image and then add it to the Flyte deck. That's it. You can add your render in your workflow file, or you can add it to another plugin. You can create your own plugin which has a bunch of render, or you can contribute to Flyte. Flyte, and okay, let me register this first. Okay, you can also use image spec. Here we use Flyte plugin deck and then pillow. Here. Okay, you register. Okay, start running. So let me show you. Here, in the Flyte, here's the Flyte deck plugin. You can see here we have a bunch of the render in this plugin. You can use like Markdown. You can give it a Markdown file, and then we can render the Markdown on Flyte deck. And then, we already have an image render here, so you don't need to implement by yourself. Yeah, so you can use this render, or if you like to contribute, like you can add as many render as you want to this Flyte deck plugin. Okay, so you see this text C. So you can clear this text, and then here's a button called Flyte deck. You can open it. Here, in Flyte we have on Flyte deck we have 3 default tab. One is timeline, one is input and output. In timeline, you will know how long it takes to download your data and upload your data, your text input and text output, and then how long it takes to execute your workflow code. Here, you can see your timeline, and then you just use the frame profiling render. So you can click here. You can see number of variable in your data frame, number of missing cells 0 is okay, and then you can see the distribution of your data frame here. Yes. This automatically created by Flyte. Yeah. And then if you go to another example, we created our own plugin. So we can see here. Yeah, it downloaded our image, the Space Needle, and then showed it on the flight deck. Yeah, and then this example, which you can see your Azure data here, everything on the flight deck. Wow. How many columns we have, like anything else? Yes. So it's flight deck. You're able to easily to explore and visualize your data on the UI. Okay. Another plugin is MLFlow. MLFlow plugin. We integrate MLFlow in Flytekit. So we create a decorator here called MLFlow Autolog. You write your training text in your function, and then you just need to write add this decorator. It will help you automatically load the metric and the model parameter, and then it will show this metric on the UI. Let's okay. Let me talk about it. So here we have another plugin, MLFlow plugin. So here we implement a decorator here. So we use the autolog method in MLFlow, and then we here we run your display. We run your text function here, and then after the text complete, we get the metric and then get a parameter, and then we render this metric parameter on the flight deck. So you can implement other plugin. You use any other tool to render this plugin. You can create another decorator and then use any other package to get the metric, to load the metric, or to load the parameter. Okay. Here. Okay. I have another example here. You can create a flight deck. Your timeline model metric here. We have the accuracy and the loss metric. You can see we have like 93% accuracy. And then you can see your parameter, your batch size. Yes. This is the MLFlow plugin. And then another plugin is the ray plugin. So a lot of people want to run the ray remote function on top of use remote function, and then run this remote function on ray cluster. So I created 2 ray remote function, and then I use it in this text. And then how do we create a ray cluster? We can specify ray config. And then use ray config here. And then here, what we have is that in the ray config, we have 2 handle config and worker no config, which define your cluster, and then that's it. You give it to the text decorator, and then we will help you. Okay. Yeah. Here, let's go to. Yeah, here you can see the cluster is creating. Is the first Flyte or Flyte propeller will create a cluster first, and then it will submit this array job to this array cluster. So here you can see, if you want to run any other array plugin or tags, distribute tags or distribute chaining under Kubernetes cluster, the first thing you need to do, in this case, we define a new tags called red function tags, so people can use this in their workflow code. And then in the red function tags, you may need to define your cluster config. In this case, it's the array job config. How many the config for the worker and the config for the handle, and then you need to override these three methods. So in this case, the pre-execute is execute before we run your array remote function, which is we call array.ini, which is try to connect to your array cluster, and then post execute is after your array text is complete, you will shut down your array cluster, and then this function get custom is used to convert your config to the portal. So when you register your workflow, we will serialize your tags and workflow to a portal buff. So you will serialize this config to the portal buff and send it to the Flyte server, and then in Flyte we will marshal these tags, this config, and then propeller will get this. Propeller will download this portal and then get this information, and then use this information to create a red cluster for you. So in the backend side, in the propeller side, we have a plugin in this directory we call the KS plugin. Some of the function you need to override is this. So you need to implement the build resource. Build resource, you need to create a Kubernetes CRD. So you may import a array job, import a array Kubernetes client or like Spark Kubernetes operator client, and then you create your array job CRD here and then return it. So Flyte propeller will know how to create this cluster for you, create this CRD for you. And then the get test phase is that in the CRD, you will see the status of your cluster or your job or your Spark cluster, your Spark job. So you need to convert this array status or Spark status to the Flyte status. So because Flyte doesn't recognize the status of your CRD, so you need to convert this status to the Flyte status. So Flyte will know this tag is sustained or fail or running. And then if you go to the array plugin here, the build resource here, we try to create a array job spec drop here and then return it. This is the build resource function. And then another function is get test phase. So this status is defined in the kubelet. So we convert this status to the Flyte status here, and then Flyte will know the status of your job. Okay. Another example is BigQuery plugin. Here, one of the use cases is that I create a Panda data frame. I don't want to save it locally. I can use structured data set, and then I can specify the URI. It's a BigQuery. You want to save this data to BigQuery, and then this is the project data set and table. And then when you return it, Flytekit will help you upload this data to the BigQuery. And then I think downstream tags, you can run a query for your Panda data frame. And then, or when you want to run like model training or another data processing, you can convert the BigQuery table here. We have a function called open. You can use arrow table to convert the BigQuery table to this arrow table. Or you can use Panda data frame. You can use a lot of data frame here. Okay, so in this example, I try to run this locally. Here, okay. Here you can see. Let's go to the GCS console. Here you can see it just created a table for me. Here contain the name, age, color, and then you can provide. You can see your data here, and then it write this data to the BigQuery, and then I print it in the arrow table format. Here you can see this arrow table. Yeah, so it's very useful in your data pipeline. You don't need to worry about how to save your data to like BigQuery, Snowflake, or like how to save data. Sometimes you may want to save this data into a Pocket file, and then Structured will help you automatically decode it or encode it to the other format, and then upload it to the S3 or BigQuery. And then if you want to use it, you just code open, and then Structured will automatically decode it and download this data for you. Yeah. The last example I want to show is Peppermill plugin. So some data scientists really like to use the notebook. So we integrate the Peppermill, which allows you to parameterize your notebook tags. So here I write a notebook, and then epoch is my parameter here. And then you can create a notebook text. And then in this notebook text, you specify your path of your notebook. And then you define your input which is epoch. And then once you register, this is the local path. But when you register this workflow, Flytekit will help you automatically upload this data, this notebook file, to the S3 bucket. You don't need to S3 credential in locally, we use data processing, help you to upload the data. Here, okay. So I register the paper. Okay, yeah. So I already run it. You can open it, and then you can. We have a feature called we have an argument called render deck, which allows you to render this notebook on the Flyte deck. So you can see what kind of you can see your code, and then you can see your what code you just run, and then you can see the output here. Yes. So okay. I just like so I just introduced some of the plugin in Flyte, but there's a bunch of plugin in Flyte. You can check out our website. So so the takeaway is that it's impossible to build an orchestration platform that is 100 feet. So people you always want to extend, decorate, or contribute to workflow orchestrator. So that's why we build Flyte. It's highly flexible, and then Flyte can be completely customized. So if you want to run your job on other platform or create a cluster, you want to Flyte create a cluster for you, you can create a backend plugin. So if you want to visualize your data, and then you want to make moving data faster, or you want to see the metric and parameter on the Flyte deck, you can implement the flytekit plugin. Okay. So if you want to know more about the Flyte, check out our website. If you want to know our product, manage a Flyte cluster, go to Union website. And then if you like these demos, please subscribe to our YouTube channel, and then give us a star on GitHub. Yes, that's what I have.
Awesome. Yeah, there's a couple of questions. That was great, Kevin. First one comes from Nerd Oscar. I hope I'm pronouncing your name correctly. So renderers, are those only for profiling, or you can use it for other visual things too?
It's not only for profiling, but most of the time people use profile render because it's very useful. But you can implement you can also implement many other render. For example, I just showed the image render, but like you can also some of the other contributor use Matplotlib. They wrote a bunch of render which use Matplotlib, and then you can allow you to show the chart on the Flyte deck. So it's not only limited to the profiler or only limited to the data frame. You can render anything like which you just need to create your render just need to create a HTML string, and then Flyte will know how to render your data or any other else. Yes.
Awesome. And another question from Nerdful. So, are the computations, are these running locally or in the cloud?
Yeah. So both. Like so, the benefit of the Flyte is that people usually iterate their workflow locally. So to iterate your workflow quickly, we support local execution. So when you develop your workflow, you can run everything locally. So it will use your local machine resource. And then I just show, and then if you run you if you want to run the BigQuery, you need a BigQuery credential locally. So and then you can run the we will submit a BigQuery job from your local laptop desktop to the GCP. But you can when you register this workflow, everything is run on cloud. So the Python text is running in the pod, and then the query text is created by the propeller. Propeller will start a routine and send a request to the GCP. Yes.
Thank you. Well, we are at time. Thank you again, Kevin. That was great. Plugins.
Yeah. Thank you, David. Yeah.
I think plugins is one of the main aspects that makes Flyte a platform, and there's still a lot to uncover. So hopefully we'll have follow-up sessions here. For the time being, thank you all for joining, and I hope to see you in next one. Bye.